The Jevons Paradox, or Jevons effect, a concept from the world of economics, comes into focus when advancements in technology or effectual governmental policies augment efficiency and resource usage. Despite reducing individual usage, the resultant lower costs spur on its demand, paradoxically escalating overall resource consumption. This contradicts the common governmental expectation that heightened efficiency will birth lower resource consumption while underestimating the potential of such effect. This anomaly was first identified by British economist William Stanley Jevons in 1865. He noticed how developments enhancing coal usage efficiency surprisingly led to coal consumption hike across various sectors. This led Jevons to argue that it can't be presumed that technological evolution will inevitably minimize fuel usage. Modern economists have revisited this topic, delving into the rebound effects of improved energy efficiency on consumption. Improving efficiency does reduce the requisite amount for a specific use, but it simultaneously diminishes the relative cost of exploiting a resource, consequently driving up demand. This surge might offset the usage reduction stemming from the enhanced efficiency to some extent. Moreover, better efficiency escalates real income and propels economic growth, thereby further inflating resource demand. When the rise in demand overwhelms, it induces the Jevons effect, leading to the rapid deployment of resources despite enhanced efficiency. The extent of energy efficiency, rebound, and relevance of Jevons effect to energy preservation remains a contentious subject among experts. Some dismiss it, while others caution that it might be self-defeating to chase sustainability through escalating energy efficiency. A few environmental economists suggest combining efficiency improvements with conservation strategies, ensuring that usage cost remains constant or even increases, thereby evading the Jevons effect. Conservation initiatives could increase usage costs through methods like cap and trade or green taxes, curtailing the rebound effect. The Jevons effect was initially chronicled in his 1865 book, The Coal Question. He observed that James Watt's inception of the efficient Watt steam engine spurred increased coal consumption in England, as it revolutionized coal as a more cost-effective power source, leading to augmented usage across industries. Despite a reduction in coal required per application, overall consumption soared, challenging conventional wisdom that fuel efficiency results in lowered consumption. In Jevons' words, it is a confusion of ideas to suppose that the economical use of fuel is equivalent to diminished consumption. That very contrary is the truth. It has been noted by economists that as vehicles become more fuel efficient, consumers' inclination to travel increases, resulting in a conversely higher demand for fuel, a phenomenon termed as the rebound effect. This occurs due to the general economic principle that a reduction in the cost of a good or service intensifies its demand. Thus, as fuel efficient vehicles make travel more cost-effective, the desire for travel rises, unleashing increased fuel consumption. This rebound effect could potentially counterbalance the initial decrease in fuel usage stemming from elevated efficiency if the rebound effect surpasses 100, consuming more than the initial efficiency gains. The scenario is identified as the Jevons effect. The scale of the rebound effect is contingent upon the sensitivity of the demand to the price of the good or service. The potential for the Jevons effect may differ in a perfectly competitive market where fuel is the only influencing factor. If fuel prices remain steady while efficiency is boosted, the nominal price of travel drops. Therefore, if the demand is price elastic, the increased travel could trigger the Jevons effect. However, if the demand is price inelastic, fuel consumption decreases as the increased travel would not be proportionate. This dynamic nonetheless gets diluted when the good or service in question utilizes other input resources along with fuel, or when external influencing factors come into play. The Jevons Paradox was revisited by economists Daniel Kotzum and Leonard Brooks in the 1980s in the context of society's overall energy use. Brooks suggested that attempts to conserve energy through heightened efficiency could inadvertently provoke higher energy consumption across the economy. Kotzum, on the other hand, criticized the oversight of the rebound effect in mandatory appliance performance standards set by the California Energy Commission. Furthermore, in 1992, economist Harry Saunders proposed the Kotzum Brooks postulate, suggesting that energy efficiency improvements could potentially escalate rather than decrease energy usage in line with neoclassical growth theory. In Saunders' perspective, when the technological progress that enhances energy efficiency is considered in light of microeconomic and macroeconomic impacts, it tends to elevate overall energy use. This notion complements both the heterodox economics hypotheses and the Jevons effect, which both state that increased fuel efficiency can indirectly promote increased fuel consumption. Nevertheless, the presence of the Jevons effect doesn't denigrate the value of improved fuel efficiency. Enhanced efficiency creates opportunities for greater production and higher standards of living. For instance, the Industrial Revolution was spurred on by the more affordable transport of goods and people. Thanks to a more efficient steam engine, however, should the Katz-Brooks postulate be accurate, enhancing fuel efficiency alone will not curb the exhaustion of fossil fuel. The validity of the Katz-Brooks postulate and the relevance of the Jevons effect to energy policy is a topic of considerable debate. Many governments, environmentalists, and NGOs advocate for policies promoting efficiency, asserting they will decrease resource consumption and environmental issues. Contrarily, several environmental economists express doubts about the efficiency strategies to sustainability, fearing any efficiency gains might give rise to increased production and consumption. They propose efficiency advancements should be paired with other policies. The Jevons effect has been used to question the utility of energy conservation measures to reduce fuel demand, stating that more efficient oil use may lead to higher demand and will not delay the advent or the consequences of peak oil. Several counter-arguments have been put forth to this proposition. For example, in mature markets, increased efficiency typically results in reduced resource use. Furthermore, even if efficiency improvements fail to diminish total fuel consumption, there are still additional benefits to be had. Enhanced fuel efficiency might alleviate the price hikes, supply shortages, and global economic instabilities related to oil depletion. Lastly, environmental. Economists argue that fuel use will undoubtedly decrease if efficiency improvements are accompanied by an intervention such as a fuel tax. Accordingly, the Jevons effect signifies that efficiency improvements alone may not reduce fuel usage, highlighting the need for a sustainable energy policy that also incorporates other government interventions. Let's talk about the paradoxes of efficiency improvements in agriculture and technology. Enhancing the productivity of a specific crop, for instance, wheat, could potentially lower the area of land needed to obtain the same overall yield, yet this heightened efficiency may incentivize farmers to switch more land to wet production, ironically expanding land use. Similarly, while the 5G network offers significant energy efficiency compared to its predecessor, 4G, its affordability may unexpectedly drive an upsurge in internet usage, thereby escalating energy consumption.